You ever look at some complex object, a part in your phone or your car, and just wonder, how did this even get made? How does something go from being just an idea in someone's head to a real physical thing you can actually hold? Well, it turns out there's a hidden language behind it all. And today, we are going to decode it. I mean, that's the big question, right? How do you take a thought, an idea, and make it real? Not just once, but thousands of times, and make sure every single one is perfect. Well, it all comes down to a language, a very specific visual language that everyone involved in the process, from the designer at a desk to the machinist on the shop floor, has to speak fluently. And that language is the engineering drawing. So what is this language exactly? Because it's way more than just a simple sketch. It's a really structured system designed to communicate some pretty complex ideas with absolute clarity. The best way to think about it is like a super detailed set of instructions. See, an engineering drawing doesn't just show you what an object looks like. It tells you exactly how to make it. And maybe even more important, it tells you what makes it work correctly. It's the master plan for everything. And this language, it kind of has two parts. Think of it like vocabulary and grammar. You've got the graphics language, all the lines and curves that show the object's shape, but then you have the word language, the numbers, the symbols, the notes. That's what gives it all meaning. That part describes the exact size, the location, and all the specs for every single feature, including how much those dimensions are allowed to vary. And that little bit of acceptable variation, that's called a tolerance. So, what happens when this language isn't spoken clearly? Well, like with any language, right? If the grammar's off or the words are vague, the message gets totally lost. And in the world of engineering, a lost message isn't just awkward, it is incredibly expensive. And this right here, this is the heart of the problem. A bad drawing leads to people guessing. Manufacturers might make the part wrong, or, and this is just as bad, inspectors might reject a totally functional part just because the drawing wasn't clear about what was actually important. We're talking wasted material, wasted time, and a whole lot of wasted money. In fact, you see the same grammatical errors, if you will, pop up over and over again. Let's break down the top 3 mistakes that can turn a simple drawing into a very expensive headache. Okay, mistake number 1, over-dimensioning. Now, you'd think, hey, more information is always better, right? Nope, that is a huge trap. It's kind of like if you asked for directions and instead of just telling you the key turns, someone named every single storefront you'll pass along the way. It's just too much. I mean, look at this. When a drawing is just flooded with numbers like this, it becomes a cluttered mess. The really important stuff, the dimensions that actually make the part work, they just get lost in all that noise. It's like trying to find one specific spice when your recipe book is just covered in scribbles. All right, mistake number 2 is pretty much the exact opposite problem, being way too vague. This happens all the time when designers take shortcuts, using generic notes or just relying on default settings instead of defining what each and every feature actually needs. And as this quote says, a one-size-fits-all approach just doesn't work. Think about it. Every feature on a part does a different job. If you don't specify its needs precisely, those tiny little errors can literally stack up across the part until the whole thing just fails. And the third major mistake, and this one might actually surprise you, is being too strict. This is where a drawing demands a level of perfection that is just completely unnecessary for the part to do its job. Here's the thing you have to remember. Making a part 10 times more precise than it needs to be doesn't actually make it better. It just makes it way, way more expensive. You're putting this huge burden on the people making and inspecting the part, driving the cost through the roof for absolutely zero functional benefit. So, with all these ways to mess things up, how do engineers make sure they're communicating perfectly? Well, they use a formal set of rules, a kind of universal grammar for this whole language of design. It's called geometric dimensioning and tolerancing, or GD&T for short. It's a standardized system packed with symbols and rules that's designed to get rid of all that ambiguity. It's not just about size and location anymore, it's about communicating the intent behind the design, the why. So instead of just listing a bunch of coordinates, GD&T forces the designer to actually think about what a feature does. Is its size the most critical thing? Or its shape, its form? Or maybe its location relative to everything else? Or its angle, its orientation? GD&T has a specific tool for every single one of those questions. In fact, the whole system is built around these 14 standardized geometric characteristics. It's this complete toolkit that lets you describe any feature on any part with total, absolute precision. Okay, so let's check out a classic example. The old way of locating, say, a hole might define a little square area where the center of that hole has to be. But wait a second, the hole is round. Does a square boundary for a round thing really make any sense? And this is the power of GD&T. There's a method called true position that defines a circular tolerance zone instead. Now, that's a simple change, but look, it perfectly matches the round feature it's trying to control. It's just smarter. And here's the real kicker. That circular zone is actually bigger than the old square one. It gives the manufacturing team almost 50% more room for variation, which makes the part easier and cheaper to make, all without sacrificing a single bit of function. So you get more flexibility for the same performance. It's a win-win. So when you adopt this new grammar, the whole process it transforms. You shift from just describing a shape to actually communicating a function. It's all about designing with intent. I mean, this picture says it all. On the left, you've got that cluttered, confusing mess we saw earlier, and on the right, a professional drawing using GD&T. It's clean, it's clear, it communicates exactly what matters. That is the difference between just noise and real information. Ultimately, what GD&T does is it elevates a drawing from just being a static plan to being a dynamic conversation between design and manufacturing. It makes sure that what was imagined is exactly what gets built. Which kind of leaves us with one last thought. Are the instructions you're giving in any part of your life just plans, or are they real conversations?